Okay, we've talked about solving systems of equations by graphing and by substitution. Now we're going to talk about a method called elimination. When we did substitution, we said that the whole point was to get rid of one of the variables because you can't solve an equation that has an x and a y in it. You can put it on a graph, but you can't solve it. So what we want to do now is make one of the variables go away using another process. First, let's think about what we would have done if we had solved this by substitution. You guys love solving for y, so you probably would have solved this equation for y and gotten y equals negative x plus 1. And then you would have taken out this y and you would have said x minus negative x plus 1 equals 7. And you would have distributed the negatives, so you get x plus x minus 1 equals 7, 2x minus 1 equals 7, and x equals 4. And then you would have plugged back in and you would have found that 4 plus y equals negative 1. Equals 1, so y equals negative 3. That's how you would have solved by substitution. There is a much easier way when the equations are set up like this. And when I say set up like this, I mean it goes x, y equals number, x, y equals number. Whenever you have equations that are set up in that form, it's really easy to simply add the equations together. If I add these two equations together, I get x plus x, which is 2x. Negative y plus y totally goes away, and 7 plus 1 is 8. Then I divide by 2, and x equals 4. Same exact thing I got by substitution, but with a lot fewer steps. And then I plug in, I'll go into the first equation, 4 minus y equals 7. Subtract 4 from both sides, so negative y equals 3, and y equals negative 3. It's still the same situation where you have to find the x and the y because we're still talking about two lines on a graph, and where they cross, we're just solving it algebraically instead of graphing. Let's try another one. That's the same one. Here, again, they're lined up, x, y equals number, x, y equals number, and you can see that if you add them together, the y's will cancel out. So let's do that. 2x plus 3x is 5x, y minus y goes away, 9 plus 16 is 25, divide by 5, x equals 5, and then plug it back into either equation, and you'll see that y equals negative 1. Now, is it always going to be this easy? Absolutely not. In this situation, the first equation goes x, y equals number. Second equation goes x, y equals number, so that's good. Everything's lined up. But you can see here, if I add these two equations together, I get 5x plus 3y equals negative 5. I didn't help my situation in any way because I still have an x and a y. It's not helpful. In order for this method to work, you need one of the variables to go away. Well, see this negative y here? Isn't there a way I can make it cancel out with the positive 4y? What could I do? I could multiply through by positive 4. And remember, as long as you multiply every single term in the equation by the same thing, you're not changing anything. So 4 times 2x is 8x. 4 times negative y is negative 4y. And 4 times 9 is 36. Everybody forgets to multiply this number. You cannot forget that. You have to multiply every single term by the number. So now this equation is gone because I have rewritten it in this form. Now I'm going to add these two equations together. So I get 11x, the y's cancel out, and negative 14 plus 36 is 22. So x equals 2. Plug back into either equation. I'll do the one that I didn't cross out. 3 times 2 plus 4y equals negative 14. 6 plus 4y equals negative 14. And 4y equals negative 20. Y equals negative 5. Let's try another one. Now this situation is even more difficult. Again, they're still lined up. X, y equals number, x, y equals number. But there's nothing that I could multiply this equation by that would make it cancel out with anything in this equation. For instance, if I multiplied this equation by 2, I would have an 8x, which wouldn't cancel out with the 3x. Or I would have a 6y, which wouldn't cancel out with the 8y. So that wouldn't help. And there's nothing I could multiply this equation by to make it cancel out with anything in that equation. So then what you have to do is kind of go back to your knowledge of fractions, and you kind of want to find like the least common denominator type thing, if you will. It's actually the least common multiple. What can I turn both 4 and 3 into? Well, I could turn them both into 12, right? That would be the easiest thing to do. Or if I wanted to get rid of the y's, I could turn the 3 and the 8 into 24. It's up to you. Whichever one you want to do will work. I'm going to do the first two. So I'm going to multiply the top equation, everything through, by 3, and the bottom equation, everything through, by 4. Because what that does is it'll turn this into a positive 12x, and it'll turn this into a negative 12x. So let's see what happens. 12x minus 9y equals 75. Don't forget to multiply the constant at the end by the number. Negative 12x plus 32y equals 40. Add your equations together. The x's go away. Negative 9y plus 32y is 23y equals 35. I did something wrong there. What's 32 minus 9? I can't add, apparently. $23y equals 35. Oh, add them together. Right. I'm subtracting. That makes more sense. 75 plus 40 is 115. Okay. So now when you divide by 23, yes, they can go to lunch. Yep, thank you. Y is 5. So then 4x minus 3 times 5 equals 25. 4x minus 15 equals 25. Add 15 to both sides. 4x equals 40 and x equals 10. Okay, so we've been confronted with all possible scenarios where you have to multiply one equation by something to make them cancel out, where you don't have to multiply anything because they just cancel out on their own, or where you have to multiply both equations by a different number to get something to cancel out. The final situation is where it doesn't go x, y equals number, and you have to rearrange it. Basically, as long as you just tell yourself, I need it to look like x, y equals number, then we can just rearrange it. So I'm going to add 15x to the other side, so now I have positive 15x. I'm going to add 48y, so now I have plus 48y. Equals, I'm going to leave the 57 on the other side. In this equation, I'm going to add the 6x over here. I'm going to leave the 8y, and I'm going to move the 22 to that side and make it negative. Again, we have the situation where there's nothing I can multiply 6 by to get it to cancel out with 15. But there is something I can multiply the 8 by to get it to cancel out with the 48. And that would be a 6. But you need to think, if I multiply this by positive 6, these two things are not going to cancel out because they have the same sign. So I need to multiply by negative 6. And that gives me negative 36x minus 48y equals positive 132. So now this equation is gone because I've rearranged it. And now I just add the top and the bottom equation together. And I get negative 11x, negative 21x. The 48y's go away. And I get 189. So divide by 21. And x equals negative 9. And then you can plug it back in to find y. So that's the gist of it.